Welcome to qnawire.
Okay, so this is the free body diagram for the car. Since the front wheels are free to roll, therefore there's no static friction at point A. So let's apply the force equilibrium for this question. So we have the net force along the horizontal direction is equal to 0, which is equal to Fb minus F cosine 30 degree. Fb is the friction at point B, and F here is the towing force we are looking for to determine. If we do some arrangement here, we have F is equal to Fb over cosine 30 degree. And we know Fb can be equal to mu s Nb. Mu s is the coefficient of the static friction. Nb is the normal force at point B. So if we do some arrangement here, we have Nb is equal to F cosine 30 degree over mu s. So now let's take a look at the moments about point A. And this equation here describe the total moments about point A. And the value with the meter here are the lever arm for each force. So we consider the counterclockwise moment is positive and the clockwise moment is negative. So if we do some arrangement here, eventually we'll have the towing force is equal to W times 1 meter minus NB times 2.5 meter over negative sine 30 degree times 0.75 meter plus cosine 30 degree times 0.3 meter. W here is the weight of the car, which is the gravity of the car. And we also know that NB is equal to F cosine 30 degree over mu s. So now we can use F cosine 30 degree over mu s, substitute for NB. So we have force F is equal to W times 1 meter minus F cosine 30 degree over mu s times 2.5 meter over negative sine 30 degree times 0.75 meter plus cosine 30 degree times 0.3 meter. So if we do some arrangement here, eventually we'll have the towing force is equal to such equation here. So now let's determine the value for the towing force. So we know the gravity, which is the weight of the car, is equal to mg. So the mass of the car is given as 2 megagrams, which is 2,000 kilograms. So if we do some calculation here, we'll have the weight of the car is 19,600 Newton. And we know the coefficient of the static friction is equal to 0.3. So now we can plug in the values back into the equation to determine the towing force. So we have towing force is equal to 2,760 Newton. And this is the answer for this question.